Okay, so we're going to kind of bring together a little bit of the stuff that we kind of hinted at through the grazing exercise that we just completed, as well as some of the stuff that Zach and I talked about, as well as probably some others with actually measuring things in the field, of bringing that into meaningful numbers, working through the math, and coming up with this animal forage balance, right? And I think there's a lot of terms out there that are somewhat confounding, some overlap, some ambiguity. Carrying capacity, stocking rate, stocking numbers, grazing plan, so on and so forth. If you look at carrying capacity, I mean, that's what we're looking at there in terms of cattle anyway, or livestock, is what can the land support on a sustainable basis? That's the carrying capacity. I think we've all seen instances of land that can carry probably quite a bit more than that for a pretty short period of time, but it doesn't take too long of that, and things start to head south pretty quick, right? A stocking rate, when we talk about a rate, it's how many and how long. That's what we're looking at. There's a few other variables that we're going to get into when it comes to that. The ultimate goal here is to match the animal demand with the forage available. That forage available being set at a sustainable mark for the plant community. Okay, and so when we look at some of the research, and some of this is some internal NRCS stuff where they look over kind of how we operate as an agency, and what kind of practices we put on land, and particularly when it comes to rangeland. It was a pretty obvious fact and subsequent statement that the stocking rate, proper grazing intensity, is the number one thing that you've got to get right in range conservation and range planning and subsequent management of grasslands before you far above and beyond everything else. And that's kind of rooted back to what I said this morning to each group. It doesn't really matter how crazy or how wild, how complicated and complex and cool, or whoever you've been to listen to as far as implementing some kind of a grazing plan, cross fencing, management intensive grazing, all this stuff. All that stuff is destined for failure if you do not have an animal forage balance. It does not matter. The grass does not care one iota how many fences you build. The grass does not care. Okay, what it sees is what it has to have to persist and stay out there resource-wise versus how much has been removed. Can I, as a plant, keep on doing that and persist in a healthy manner? That's what it sees. It doesn't see the 15 fences and 20 paddocks. It doesn't care. So stocking rate and getting that subsequent grazing intensity at a mark that's profitable yet still sustainable for the grassland is the number one mark that we're aiming to hit here. So if you were to take nothing else from the next 40 minutes or so of me talking, it would be this equation right here. So, and we'll kind of step through what each facet of this really means and kind of how to apply it. But this is the equation. And so if you're if you weren't an A student in algebra and you want to work through this, you might need to touch up a little bit. But you can see that, I mean, this is all multiplication and division over here. So we can rearrange variables. We can, if we have a handful of information here, we can solve for another one. So we may not always be solving for animal number over here. Maybe we know the animal number and we're solving for the amount of time. That sort of thing. Typically, acres are foregone conclusion. You know how many acres you have available to you. So that's usually not a variable we're looking at. We're typically either looking for, the herd size or how long they can stay. Okay, and that's all in this equation. Okay. So, as we mentioned earlier when we were out there doing the quadrant frame clipping, we're looking for total annual forage production. So there's total above ground production. Is all that forage? It's important to think about and know from a site from a site production and a site health standpoint. But now when we go to convert all that into a stocking rate, is it all forage? What happens if we clip 5,000, if we come up with 5,000 pounds to the acre and we hinge our stocking rate off of that, but then it turns out that there was one species in there that made up 2,000 pounds to the acre that we know for a fact they're not going to eat. What happens to the other 3,000 pounds to the acre that was forage species? It gets hammered on, right? Because we've put that many animals in there, but they're not eating the margin of what we said they were going to eat, right? You've already been walked through the site potential. That's all linked back to your soil type and how much of each one you have. So ecological sites, we look at the mapping of those, what proportions they are in a given grazing unit. Quantities and vigor to plant. A lot of stuff really depends on what has occurred there in the past. Has it been hammered for the last 100 years, 50 years, 20 years? Where are we starting at to build from? Not every pasture is created equal. Non-usable or reduced forage acres. So, feeding acres, ponds that have had big areas of impact around them, areas of dense tree canopy that have very little herbaceous growth beneath them, and reduced or sometimes even zero forage. And then we hit on this a little bit today when we talked about reconstruction and the thought of percent climate. And it's kind of a tricky thing to account for. But we could say maybe they've received 15 inches of rain, but if it all came in 3 5-inch toad strangler rains, how was that really effective rain? And then Doug talked a little bit this morning. What kind of vegetation is out there as far as infiltration and effective rain? It's all buffalo blue grama sod. A lot of that stuff is sheeting off. You're not getting infiltration, particularly when it comes to buffalo grass. Tends to infiltrate a little bit better on blue grama. So think about if you have a whole bunch of sod-bound states out there, is precipitation really effective? So in other words, if you're thinking that you're way ahead on rain just because you've caught that much in your rain gauge, did the plant really realize that from its perspective? You need to be thinking about that before you immediately go out and buy another 50 cows. All right. That statement's in there. I encourage you to read that. Kind of a little bit of wisdom there. No, Ed, we ain't overstocked. We're just under rained, and I think the further west we move in the state, I think we feel this quite a bit. But optimism should not be segregated from inaction. Optimism really isn't an excuse for inaction. If it doesn't rain, you need to be pulling back. We're going to talk about that here in a little bit. We hit on this a little bit this morning. So we talk about average precip, average production, average. What is average? Well, average in reality is nothing more than a mathematical phenomenon. And this graph shows that pretty well. The green line is this comes out of MORA 76, which is Flint Hills, but the graph would look very similar for out here. This line would just be down around here. The whole thing would be shifted down. Green line is forage production. The blue line is annual precipitation. And you can see that they do in fact mirror each other in trend. Oftentimes there's a little lag. And then you've got that dotted line across the middle, and that is the average. But in any given year, does the average ever really happen? No, it's just a product of math. But it's still important because we have to have that foundation to work off of. Okay. We hit about this a little bit earlier when we were talking about the thought of reconstructing what we clipped in that frame, and understanding that what we clipped today didn't really represent the total end of year forage because we still have a little bit of forage yet to grow, right? This is your standard. The green line that's a mixed grass curve. The short grass curve is very similar. The warm season plant growth curves are both bell curves that that very much so mirror the bell curve that is our precipitation curve throughout the season. All right. All right. So here we have a kind of an average range land unit. We're going to start to consider soils and ecological site information on there. We have inventory and the other anomalies when it comes to forage production, ponds, trees, these sorts of things. So we could take this same slice here for an ecological site out here, and you'll find that ecological sites. This is what Chad and Kim were talking about this morning. As you move in different positions on the landscape, we expect to find this repeatability of ecological sites that's associated with the soils that exist there. Right? Yeah, down at the bottom, I think a lot of us get roped into like, well, what's the stocking rate for Logan County? Like, well, that's a pretty silly question, because there's a lot of average stocking rates, but I've yet to find any average pastures. Well, coffee stops, the local co-op, probably not the best place to acquire your stocking rate to hinge your whole ranch management plan off of. Okay? So what about the usable forage out there? I think as we move into the central and eastern part of the state, we see a lot of this situation, and as tree encroachment expands, and people are still stocking, a section of ground for 640 acres of forage, and we haven't accounted that 40 acres of it are now consumed by woody encroachment and are now either growing zero forage or causing a situation where there's zero accessibility to 40 acres of forage. Okay, so we need to take that into account. A situation like that, I would take those acres and I would just zero them out in the weighted average. Okay. So that goes for trees, ponds. Doug pointed out yesterday when you all were out there trying to figure out how much forage was there and how many animals we should put in there for one day. What about, that was a 4.6 acre deal. What about that 12 or 15 foot wide beaten down trail that ran diagonally from one corner of the neck to the other? That thing ran 800 feet across there at 12 feet wide. We could calculate that. If something like that is a minute thing on a 3,000 acre field, it's not that big of a deal. On 4.6 acres for one day, margin of error is pretty big there. That's on a percentage basis, that's considerable. You have to start thinking about stuff like that. Okay. So when we start kind of blocking things off into categories for forage, we might look at it like this, where we have our brushy areas that we're going to reduce forage availability there for brush. This is a pretty common scene. I think this ranch here has some of that. If you have an old go back or a seeded back area that kind of is fenced in with the rest of a native range field, probably want to inventory and consider that separately. I can assure you that it's going to graze differently. It's probably growing forage differently. It probably has a different species composition. And now in the age of expiring out CRP, we see quite a bit of that. CRP that had an old crop line that was pretty sinuous. It was once fenced out, but it was a real pain to have a fence on a line like that. Kind of turn that into range, and it eventually gets fenced with the native range. It's a good plan. It's fine. There's a few management things probably I'll consider when we do that, but we certainly should consider it a little bit differently when we inventory the forage. So yeah, we got the pond, native, most of it native, trees, pond, go back. Yeah, so you can kind of see this is all on top of and in addition to the weighted average that we're doing for the ecological sites on that native range. Okay, so anything ecological site or stuff in addition to ecological sites that I have a good basis to assess differently, because it is different. There's which one of these is not like the others? Well, that. Okay, let's go look at that and assign a different number in pounds per acre to that. We can measure the area and then include that in our weighted average. Okay, and it looks like something like this. So, you know, in your traditional sense, we've got our native range, we've got our ecological sites. You know, we've got our estimated pounds per acre here, and then multiplied by the acres, we get our total pounds. And then we bumped on down to the next category. We had two different ecological sites that were consumed by moderate brush, two ecological sites that were consumed, well, portions of that were consumed by heavy brush, so on and so forth. You can kind of see how this goes. Anything that we can, the more you can dice that out and really get down to the gnats behind on measuring stuff, the better your answer is going to be in the end. So here, this will be your weighted average. We get a total production divided by the total acres, and we end up with 3,330 pounds to the acre in that scenario. Okay, for that field. That would be the number that we would then use to start figuring a stocking rate for this field. Okay. Now we're going to get into a little bit of the concepts of utilization, grazing efficiency, and harvest efficiency, and why these numbers are where they are. You know, there are some management systems where we can kind of toy with those, but for simplistic speaking, there are kind of some rules of plant sustainability and vigor and grazing animal use that we kind of set pretty static numbers for all these items. Okay. First, we'll start with the concept of utilization. And when you start thinking about utilization, the first thing you got to realize is what we're really doing here. To make a plant sustainable, we have to have healthy roots. If you think about your typical perennial native grass plant, warm season grass plant, out of all the growth that occurs in a year, we only see about 1/3 of that. That's what we recognize as growth. That's above ground. The other 2/3 is below ground. So there's a whole lot of root growth going on down here. And as those roots grow, they're sloughing off exudates, so on and so forth. And you have to realize that in addition to growing and expanding a bigger, better root system, that plant is in the process of doing that. It's also having to replace a lot of the tissue that's already there because it exudes off, oxidizes, so on and so forth. So there's a lot of root replacement going on. Okay. This is on the flip side of that single page I handed you there. That picture's been around since 1949. Picture's worth 1,000 words, right? So in this instance, these are this little blue stem is a bunch grass, and this is little blue stem. Some of it that was continually defoliated at a low level, a moderate level, and then some of it that still had quite a bit of leaf material intact. And you can see how that related to its root health. Okay, it's a pretty linear relationship. If you continually defoliate something, this is the kind of root you're going to end up with. And when we say that even in the absence of a climatic drought, you can literally graze yourself into a drought, this is what we mean. If you graze off here and your roots are like this, your range and your plants may be actually experiencing a drought when there's not one. Does that make sense? Because these roots have so much more capability to gather moisture, right? They have more surface area, far more surface area. So this is kind of building to the concepts of the utilization.
Right, wait on that. That's just interesting into that line on the right hand side that has 75% managed. So that's what we're making. So you can visually understand from the by lane and the master 75% less than that, right?
Yeah.
To the left.
Quite a little bit. So this is where so thinking of all those concepts and understanding what we have to do to keep the grazing resource healthy, we have to keep the roots healthy. The utilization rate 50%. Take half, leave half. The rule of thumb, right? It's kind of catchy. Half and half. Pretty simple mathematically, right? Kind of seems like somebody like, let's just pull that out of our rear and we'll put that there because it's easy to remember and it sounds good. Well, that's all true, except for the part that it got pulled out of the rear. It turns out that it's rooted in some pretty solid numbers. And so we're comparing the percentage of leaf removal, percentage of leaf that is removed, to the root growth stoppage rate. Okay, so if there's zero root growth stoppage, the roots are growing uninhibited by what's going on above ground. If there's 78% root growth stoppage, that means the rate has slowed up by 78% compared to what it could have done otherwise. Okay, that's what we're meaning here. So as you can see, we can remove 30, 40, right up to that 50% mark and really have zero to negligible effect on that root growth rate. Okay, but look what happens when we go to 60% leaf removal. There's a tipping point there, and it drops off hard. It's not subtle; it's hard. And if you think about the effects of having a boo-boo in grazing and the recovery from doing so. Obviously, the further west you move, at least in our state, and the more arid environment you move into, the more drastic this effect of going past this point is going to be. This is big from the plant's perspective, and if you continually do this year after year, it's huge. You are in a self-induced drought almost all the time, is what you've done to yourself. So that's why the concept take half, leave half. And I like to add a little bit of something to that. It kind of depends on where you're starting at, but if we're kind of trying to rejuvenate some range that's maybe been historically abused, we implement take half, leave half. We may do some growing season rest sort of things. But the concept, if you're starting down here and the potential's up here, then I think you could say take half, leave half, and over time, the half you take will get larger, because we should be recovering forage and plant health, and we should be upping annual production. Does that make sense? Okay, so we talked about total annual forage production. What about harvest efficiency? And this pictorial is also on the back of that sheet. So there's a couple things, all concepts, and they're all interlinked. We have utilization, we have grazing efficiency, and we have harvest efficiency. Okay. Utilization, we set that right off the bat. That's right here. We're automatically going to leave 50% of the leaf mass, the leaf matter. We're going to leave that because we know from right here, that's what we have to leave to keep the roots healthy. Okay. So now we're working on this 50% up here. That's what we can take. Now maybe it's not that's the wrong term, really. That's what can be taken from the plant's perspective. And it doesn't really matter who or what takes it. Okay. It might be the animal. It might be peed on, pooped on, trampled, bedded down on. Insect herbivory is a big one. Especially certain times of year, you get out there and there's just seas of grasshoppers up, those things are consuming stuff. I frequently go into the field. I'm out there squatted down, clipping my frames. I got my wooden clipboard with my paper on it. I'm recording everything, and I turn around and half my damn paper's gone because the hoppers have ate it. And that's no kidding. I've actually had that happen where they've literally consumed half my sheet of paper on the top of my Big Chief tablet in, 20 minutes time. So they're definitely eating some plant mass, right? From the plant's perspective, it does not matter how it's taken. If it is no longer photosynthetic solar panel energy producing material to put energy into those roots, it's take. Okay. So here's where we introduce this concept of grazing efficiency. So of the 50% that we're going to utilize for kind of the more, not the 1 day thing, this is a good distinction. So we kind of merged grazing efficiency and harvest efficiency into one because it was just a 1 day event. And I think we have 80% for 1 day for our demonstration. We're talking about more over the course of a grazing / growing season here. You introduce these concepts and kind of separate them. Okay. So out of 50% we utilize, grazing efficiency is approximately 50%. So 0.5 times 0.5 is what? One half of one half is what? It's a quarter, yeah, 25%. And that then ends up being your harvest efficiency. Okay. The harvest efficiency is the amount of is the percentage of the total annual forage production that we plan to ingest in the animal. And so usually when we do grazing equations, we just jump straight to the chase and go right to our harvest efficiency that you can apply directly to your total annual forage production. But it's important to know where some of this comes from, because you will get into situations where you'll see multi-paddock rotational systems that might have a harvest efficiency that's a little bit higher than 25%. You'll see some 28, 29, maybe even 30% if we get a lot of paddocks in there. And so what's going on there? Well, we've got a lot of paddocks. We've upped the stock density, the number of animals that are there for any given moment in time. And in doing so, we've caused some animal competition. We've caused them to bite into a few things that maybe they wouldn't have otherwise. We've maybe beat the grasshoppers to some of it. We get this pretty even graze, and so what actually happens there is the grazing efficiency ends up being a little higher, which then makes your harvest efficiency a little bit higher. But that's about all the bump you get. And I want to be very clear about that. And I said this to a group last week. I think there's a lot of misnomers out there about particularly rotational grazing systems, whether they're just simple rotations or rest rotations or any kind of management intensive thing, like, well, it's build all this fence and start rotating cattle and you can double your stocking rate. And that is, to put it bluntly, 100% BS. Okay. We're talking about moving from like maybe 25 to 30% harvest efficiency bump, 5% at the max there. Now, what those systems will do, and probably what the focus should be on, that's the animal production side of things, right? What the focus should be on there is what's it doing for the grass plant? Well, it's providing growing season rest. And so if we're starting with kind of a diminished plant community and we're wanting to recover stuff, that may be part of the plan that we need to implement, is some manner to get growing season rest. And if you got nowhere else to go with them, then we need to subdivide to make rotation to make that possible. Okay. All right. There is your harvest efficiency stuff there. You can see, native range, and then tame, which is pasture, but in the true sense, agronomically manipulated tame grass, brome, fescue, Bermuda, these sorts of things. We have a higher harvest efficiency. Why? We're controlling some other factors there, right? We're dumping agronomic inputs into those plant communities. So there's a benefit in bump here, but it's coming at an input cost, right? All right. So we hit on this a little bit, and I think hopefully everybody had the chance to eyeball some of the western ragweed, the kochia, and even the Russian thistle that was out on the patch we just came from, most about all of which have been at least topped by cows, even in the 24-hour period they were out there. When we look at forage, it's not just grass. And we have to get away as a community of grass managers. We have to dispel the thought that anything that's not grass is a weed. We have to get rid of that thought. It's not good. It's not healthy. Certainly not how the cows view it. Bump over that. Yeah. So here's a average situation. You might have 70 to 75% grass and 25 to 30% forbs by weight out there. Right. Even in law systems where maybe forbs only make up 10 or 15% of the plant community by weight, through the course of a 6-month season, cows will frequently graze 25 to 30% of forbs as part of their diet. So if it that means those animals are specifically out there hunting for some of those plants during certain times of year. So, forbs are important, not just for the health of grassland and all the wildlife benefits, but also from a forage-based standpoint as well. All right. So that's our forage inventory. I think what we'll have you do, rather we can use some of these numbers here, but on the backside there, we're going to work through. So we're going to set a little bit of fictitious stuff here. But from the three groups that we clipped in today, Zach took a straight average of those production figures, and he came up with 1,556 pounds per acre. Okay, which will go in your second yellow block up top there, right? And I don't know how big how big is that acreage that we were in out there, Cody? That area that we were clipping in out there today. Okay, well, let's make it just for example's sake. Let's say it's 200. It is truly just a trap then. Okay, let's say it's 250 acres. That way, we'll actually come up with a manageable herd. Okay. So you can start working that across there. And let's go ahead and assume a harvest efficiency of 25%. What do we come up with for available pounds of forage dry matter? What'd you get, TJ? 97,250. Everybody coming up about that? Okay. All right, so we'll keep on working this example through as we step through the rest of the equation concepts here. Okay, so now we're on the bottom end of the equation here, which has to do with livestock demand. All right. You know, I think it's one of those deals with bovines, particularly if you're unsure. Certainly, this varies through from one animal class to another, and it certainly varies with the cow where she's at in gestation and lactation and so on and so forth. If you're unsure, I would just use 3%, okay, because you're going to be on the safe side there. You know, I think dry cows that have pretty well bounced back after weaning, non-lactating cows, 2.5, 2.6% is pretty reasonable. I mean, we can toy with some of that if you have that inside knowledge to be able to mess with it. If you don't, I would just use 3% of the body weight is consumed per day, and you'll be safe doing that. Certainly for any kind of a growing animal, heifers, stockers, steers, 3% is an applicable figure to use. But just kind of to bring it all together, different animal classes here and different sizes of animal, it certainly matters. And I think Justin kind of alluded to this fact to you all yesterday when he was asked how heavy those cows were. And what did he say? I think his words were, if you ask them, they would tell you they're all 1,200-pound cows, but really they're probably 1,300 or 1,400 pounders. I think that's what he said, and I think that's kind of the common thing we find amongst ranchers, stockmen. Is the thought of the cow size is just increased and increased and increased, and sometimes unknowingly. I think we all like, oh yeah, the cows are 1,200 pounds. Like, well, I drive around the countryside, and there's a lot of 1,400 to 1,600 pound cows wandering the countryside. And there you go. Yeah, I've seen this done a couple times. It's kind of I don't know. It's kind of a startling exercise, really. In the dead of winter, when there's not a whole lot going on, and some county extension agent will put on a little to-do at the local sale barn, and they'll have somebody bring in a load of cows of kind of varied size, probably varied age cows, and they'll run them all through the ring and say, number 762, and everybody's got an index card, and everybody in the crowd writes down what they think she weighs, and then they put it all up on the screen for you later, and we find out that nearly every time, most people in there have grossly underestimated the weight of the cows. Because, you know, they're not a stalker. We don't commonly weigh truckloads of cows. That's not, you know, that's not the way the industry works. And so we kind of lose track of what cow weight is. But as you can see, when we start thinking about getting the appropriate stocking rate, it's pretty important to know where you're at, because that animal forage demand, I mean, you know, this may not seem like a huge difference here, but if you spread that over a herd of 200 cows, the herd demand difference there is fairly drastic. Okay. Okay. This is a stalker situation. We won't do that. We're going to use cows in our scenario. What do you do in a stalker situation? They're going to go in at one weight, they're going to come out another weight. So typically, we'll figure the demand for the average weight, the projected average weight for the time they're there. So if we think they're going to go in on such date, they're going to stay for 90 days, we expect them to grow 2 pounds a day. So we're going to put on 180 pounds, add that to the end weight, take the average. There we go. Okay. All right. So let's go ahead and work through this with our cow. We want to know how many cows. We're going to say that they're 1,300 pound dry cows, and let's use, I don't know, what's a 2 point what for a dry cow? See, 2 point. Let's use 2.6% average daily intake percentage. 2.6.
Show here.
Right. Yep. Okay, let's say that we're going to leave her there for 60 days. So one cow of that size, that average daily intake over the course of 60 days, will need how many pounds of forage? What'd you come up with? 2028? What everybody's got? Okay. So now quickly bump down to your final line there and figure out how many cows we can have in this 250 acre grazing unit for 60 days. What'd you get, Tanner?
48.
Yep. Yeah, we don't cut cows in half. So. Yep. 48 cows. Is that what everybody got? Okay. So we're taking some ecological concepts, a little bit of knowledge about animals and animal growth, and converting this into some meaningful numbers for stocking. Okay. This is something that gets talked about quite a little bit, that similar to this concept here, I think kind of gets missed sometimes. You know, like, oh, it's not that big of a difference. Doesn't really matter whether she's 12 or 1,400 pounds. Similar situation over here. Well, I don't, you know, February calving, April calving, you know, it's all spring calving, right? I ask people, you know, like, you know, and certainly people have reasons for doing things. You know, you've heard the Youngkins talk. I mean, they're clearly they're marketing seed stock animals, and so there's some marketing reasons as to why they're doing what they're doing. Fine, you know, kind of what fits. I think probably what's not good is doing stuff just because that's the way Dad did it, and that's the way Granddad did it, and making sure if there's good basis for that, then great. But I think there's some valid questions to be asked there, you know. And I think I ask people frequently, well, when you calve? Well, springtime. Like, well, what month? Well, you know, I don't know, February. Like, well, I'm still wearing my Stormy Cromer hat and my wool Mackinaw with the collar popped up in February. That ain't spring. Okay, but in fact, is pretty much the coldest month we have in this state. Okay, that's not spring. So you start thinking about a calf at mama's side through the growing season. The earlier she hits the ground, the greater forage demand that pair represents throughout the season than a calf that hits the ground later. Does that make sense? So you can kind of start to see your differences here as you come out at the end of the year. It's pretty drastic. Okay, so yes, if we're all going to wean at the same time and we calve earlier, we have a higher weaning weight at the end here. But if we're gonna make sure that we have animal forage demand, we've got far fewer of these calves to take to market than we do these calves. And then you need to really start looking at things pretty hard. Does that really make sense? Okay, because yeah, they may be worth more money, but they may not be worth more money. And there are market times when they're not worth any more money. You'd be better taking more of them to market. Okay. You also have to consider everybody knows what kind of battle calving during this time of the year looks like, or what it could look like. Okay, all the death loss, the doctoring, the scours, everything else that happens February. What happens if you get hung up in a February snowstorm? Okay, and the cost of that. What about the extra feed input costs? When do bison calve? When do deer fawn? Yeah, it's not February, because if it were, there would be no more deer. Okay, they're fawning when the resources are available. Okay, a cow that's calving clear back in February is going to have to make it through February, March, and a pretty good chunk of April before the forage, the high quality forage that's needed to support a lactating animal really comes online. And so from a producer standpoint, you have to make up that margin, and it's all input costs. Okay. So, and all this is chewing into that margin that heavier calf may have been worth, if any. This may all be actually really costing you money. Certainly something to consider. And definitely, and that's all in the background of an individual outfit's production scheme. At a bare minimum, we need to understand that this makes a pretty big difference in how our animal forage demand, our balance plays out. Okay. All right, and this was a whole work through of equation, but on an apples to apples scenario here, get down to the bottom. There we go. There was a situation that had 27 pairs if they calved in February versus 31 in April. I guess that's all I had. I had 2 inch spectrum. So, in that scenario, there were four more calves to take to market. Okay, what were those worth versus the margin of what each of them would have been worth at 27 had we had the heavier calves? And then subtract from that all the input cost, February, March, and April, and all the griping and moaning and everything else that went on from calving during that time of year. Most people I know that moved out of February calving into March and early April have never looked back. Okay. Now we're into the measuring and monitoring. We won't hit this too much. But it is important to come back. Once we've set the stocking rate, we've put it on to a grazing plan, we've implemented the plan, we've started in. What happens if we go back and monitor and we find some stuff that's not quite right? Well, we need to adjust. And it certainly can happen. It certainly can happen. As I hope you all saw this morning when we were clipping quadrat frames. I mean, it matters pretty big time where you lay the frame, making sure that you've encompassed the variability that's out there, making sure that you've appropriately reconstructed the dry weight forage. percent wet matter, percent growth, all these things. You got everything accounted for. Okay. So while we should definitely be in the ballpark, what if all this is done right? You know, I've been cranking out grazing plans and following up on them for coming up on 20 years. And I'd be remiss if I said that I cranked them out perfect every time. That just simply doesn't happen. We oftentimes are adjusting them, we're tweaking them. If we're not, we definitely should be. Okay. And then there's the concept. I mean, what happens if we come out and we find something like this? Well, the first instance, if that's the only picture I showed you, it would be like, oh shit, you know, we got problems. Maybe we do. Maybe we have maybe one corner of it looks like this and the rest of it is grossly underutilized like this. Well, that probably our stocking may have been okay. We have a grazing utilization or a distribution problem, right? And then we need to start thinking about, you know, maybe we could patch burn patch graze, maybe implement some more water development somewhere to move those animals around, salt mineral, moving that around. You know, there's a number of things we can do to affect grazing distribution.